All right, we are back. Yeah. I'm surprised people aren't not impressed, but like surprised by how easy this was. But really, the reason this is easy is um, like we already had the type interning. If you didn't have the type interning, this would be a nightmare because then you would have to implement interning just for type IDs, I think. So, um, one of those cases where good design decisions keep paying off, not just once, but in succession. Okay, type info, type info, type info. All right. Let's actually let me get a drink and then I'll actually let me go to let me go to the bathroom for a second. I shouldn't have started recording and then go to the bathroom, but I have to go to the bathroom. I'll be right back. All right, let's get into it after a drink. All right, type info. Um, so what do we need? Well, um, I already created this, and this will have to change now, I think. Um, let's rename it. I'm not using a union for this out of laziness, I guess. Let's just keep this as a struct for now. All right, so let's see if there's the right data here. Type field, type info. Let's not do symbols. That's pretty easy to do, but let's do that later. And so really all we want is a function called get type info. which takes an ID and returns a type info pointer. And this is just going to be the standard preamble, whatever, the standard thing that's included. And we'll have a better mechanism for including these in the future, but for now it's just next to the filing question where we're testing. And so this is just going to be the accessor. And so you're not supposed to access the table directly. You're supposed to go through this function so it can be stubbed out with get null, returns null or something like that. And so I think one thing you want to do is there should be, I'm going to not actually declare them here because I want to synthesize them. No, I guess I should declare them here. Right. Yep. Num type IDs int type info table type info type info table. How do we want to insert that? I think from a certain point of view, no, I think from this point of view, we just want this to be it's a pointer. No, I think just like that. Something like this. Or maybe it's just like num type infos, and then type infos. Maybe like that, that's fine. And then what we do is we say if type is less than num type infos, then I think we just return a pointer to that entry. Otherwise, we return. No, that can't work for missing entries. So actually, let me do it like this. And this is null. So those entries. So then we can have things be sparsely populated, like this. I wonder why that crashed. Oh, right. Okay. How was that crashing? Maybe it wasn't crashing. Maybe I was just not seeing the. I think I'm going to make type ID be actually assigned int just to try to standardize on normal ints as the type for this stuff. Now that I think about it. compilation failed and then no specific error. That's odd. Let's so go to the generator. Ooh, what's going on exactly here? Okay, so clearly something about that. Um, Sorry, there's something weird going on. All right, so built-ins. So what is our task on the C side? Our task on the C side is, if you look at, so this thing is going to be initially null. And actually, let me even write it like this, because we want to allow for the fact that this has not been assigned. If we then look at get type info, okay, that looks reasonable. Then I want to, in the generator, I'm going to make a genTypeInfo function. I think actually I want to make this a foreign type, so that these things can be something really weird with the build system and the calm down there. This is because I set the wrong dependencies. Test1 ion, test1.c, test1.ion. Oh, it's because I probably need to add this one. I hadn't thought about that. That makes sense. What? Why does it say it can't? Something about the build dependencies must be incredibly jacked up. So it says compilation failed, which I think can basically only happen with that specific error. I should make some better error messages. Um, it's because the working directory is wrong, I think. It's using the working directory. Oh, it's probably using the Noir working directory. No, it's really not. Let's hard code the path for my machine, which is kind of dirty, but I just want to get this working right now. Okay, finally there's stuff going on. Must return a value, blah, blah, blah. All right. That's at least what I was expecting to see. Okay, so these things are now foreign definitions, and so our generator is going to define them. And so let's just stub them in really simply for now. After everything else. Or at least after this. Okay. So here we have the stuff stub in, and at least kind of links up. Now, let's do this assignment, and then we're going to do type info, table, something like this. And then we're going to do a bunch of stuff. We currently don't have a reverse mapping table, which is convenient for this purpose. So let's make one of those. You don't necessarily need this, but it's definitely useful. So the key is going to be the type ID. I'm just going to cast this. This can't be 0 anyway, so we can do this directly. And then we associate it with the type. Okay. Let's just remove this for now. Num_type infos is an int. Type infos is the pointer to a table of type info pointers. How is that even compiling before? Okay. And maybe we'll do a little interface to this. All right. So let's see here. So I think we're going to go through this table, starting from 1. So I think we generate a null pointer for the first entry. And then because this is actually right. Because even if there's many type IDs more, we might have a narrower range of type infos. We don't want to generate a bigger table than necessary. So I think that's the right naming. So now that we have this, if we don't have a type, then we could legitimately also do this for 0, except that Actually, this is a good idea. Let's make this bulletproof. We don't have to special case it and kind of transfer that concern over here. So generate just a null entry if there's nothing there. All right. And then I guess we have, let's see here. So you have to switch on the kind. So maybe we don't generate thing, like we want to be able to test it piecemeal, so I'm going to just kind of skip it for some things. And then you say type int. You want to say, well, first let's look at the struct. Let's look at what the struct actually says for type info. Size is size of int. Line is size of int. Count is kind of irrelevant. Let's generate something fairly readable if we have to debug it later. That way we can also skip the fields we don't care about. So already this should do something useful. Kind of useful. Okay, not very useful. This is also way too small a table. Why did it only generate 75 entries? The other side of it is we really want this table to be explicitly sized, just to prevent bugs. Otherwise, the bounce check is not correct. So that's interesting. So let's see. If there is a type, then let's formulate the code a little bit differently, since we're not doing stuff here. Actually, the code I'm writing is also wrong. It should be like, let's see. It's a pointer to type info. So I'm going to use this notation. Oh, we can't skip it like that, so we have to let's just put that in there so we can kind of look at it ourselves and see that stuff is being skipped. That was the problem. Okay, so here's emitting null. So these claim not to have an associated type. That's probably just because the hash map is not working as I was hoping. That's fine. Oh, it's because all the base, gotcha. It's because all the base types like int don't have registrations in the table, which makes perfect sense. Okay. Does the C code actually compile? I guess it should, right? Okay, it does. So in theory, we should be able to now go to test1.ion and actually get the type info. From int. All right. And then we should be able to actually let's make the function take a type ID. Okay, so that didn't hit. So that was type info of int. So what entry is this? 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh, I think I know what it is. It's because I didn't hook up the pointer here to the table. Yeah, that's okay. So I think that's on the right track. We just need to fill that out. So for these basic types, I think we need something along these lines. And I think I'm going to use a macro. So it's going to be like kind and C type. And it's going to be this here. It's going to be this. It's going to be some of this and some of this. And some of this. First, let's just remove all these extra cases and see if we can replicate the original behavior from one from one of these. Let's just call it case. So case type int, boom. It's this. Let's see what the typo was. Oh. Type int. So it didn't regenerate. Okay. It still puts correctly. Let's probably just have that case manually. Just leave it like that. Okay. Let's see here. Okay, so that's just for the built-in stuff. Then we have to generate, let's see, all these derived type constructor things, like, just write out the list. Pointer array, blah, 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 all of these. These are the same case. Maybe we'll skip functions for now. And then we'll make this actually a insert now that we're trying to cover the cases. So for pointer, of course we'll have the same thing as usual. But then we also need a base type. And this is essentially this, I think. And this is kind of similar. This is hard coding. Let me see here. Maybe I want to generate the actual C decals. Like, actually, yeah, let's test that with this. If I did size of, and remember with cdecal, what do I call that function? Gen cdecal Type to cdecal. Type to cdecal. How does this work? Let's put these under this case for now. So this is a void star because it's pointing to field 1, which you can see is void. Then we have a bunch of pointers here. And that all seems reasonable. Does that work for this, I wonder? So this is probably putting this stuff really through its paces. Even though we're assuming certain things about the backend for the type info in our resolver, I'm trying to not hard code that info in the type info table, so this stuff is more portable on the C side. I'm curious about these type errors, though. Cast to function type is illegal. Okay. There's clearly some of this. Yeah, so it thinks this is this is not a function type. Maybe I should say gen type info header, and that will do kind of this stuff. Yes, we don't need it for the rest. This is pretty self-contained. Now we're back to something more reasonable. Okay. Oh, so this is not even. So it is getting confused by these types. I should really. I really want to manually build this so I can see where the actual error is. I guess it's this one. So if x is here, first we dereference. No. First we index, then we dereference, then we have a char const. So this is a pointer, an array of pointers to. Right, so this is an array of names. I think this is, in general, this kind of code should be fine, right? I think it's this. This is not allowed. So I'm generating extra parens. Yeah, this is not legal C. You're not allowed to have those extra parens, but it could be like certain. Yeah, this is the problem. I already have something to deal with that though. Why is that happening here? So this is for. I have this C decal. Oh, maybe it's because. Okay, let's work through this. So we have an array. And we should be doing optional parenthesization of this. Based on whether the string is non-empty or not. So only parenthesize it if that thing is non-empty. So why am I not doing that? Because, well, actually, easy case, so let's just step through it. Why is it even building that? Yeah, load that shit. Right, this is not the case I'm interested in. I think this is probably it. Yeah. So let's see why this thing is not doing the thing. So yeah, that's definitely not correct. Because the thing that it's like, so it's already generated. I don't understand that. So it's okay, that is correct. I think, right? Because B is false, so it should not parenthesize it. Wait, where did that happen? Let me try that again. It was the third one. Right. So this is the one. F12. So at this point we're saying we don't want anything there. We step in. The format is, right, this is where we put together, so it's 256. That's right. Stepping out instead of stepping in, that was my fault. Right, so now we have that part. And right, it returned that. Now it calls for the base type, it calls that with, I see. Let's do something hacky. If I think all the current ctuple uses are passing in the first character anyway. sure there's a better way of doing that, but don't really want to rabbit hole in that. I'll write it to do for myself. Okay, now things look better. Let's reload it. Well, first let's try to run it. Anyway, that seemed to work at least. So type info table. Have all these types. Now let's expand that. So num fields is I don't know. What's that thing called? Aggregate.numFields. Type Back to doing stupid shit with the dependencies. Because if that works, why is it? Oh, this workflow is getting on my nerves. I'm really gonna have to ditch it completely. It's nice to be able to work on the compiler and the program at the same time, but sometimes when stuff like this happens, I'm just losing my mind. Right. Oh yeah, there's no base. Why am I trying to print the base here? It's supposed to be the generic stuff. Field 3. Oh god. I must be getting tired with this shit. Okay. I think it's time to finish this and wrap it up. Okay, it looks like, let's see here, alright. It's not looking like it's been regenerated. Void, what's after void? Oh, we don't have bool. So we're returning type ID. There should really never be type ID pointers. So I wonder where those are coming from. Yep, it's not correct. Guess we have to make sure they're in the right order. Okay, almost done. Okay, we have rules. Um, there's still unhandled kinds. What those are? Oh, const. Right. Guess we probably do have to handle those separately as well. Which is fine. Oh, actually, the other thing we didn't do here is count. Not an element, I think it's called in that struct. Yeah, so this is actually not right. Should never be possible. I don't want to make this kind of defensive programming at the leaf level is a very bad habit. Let's see. Only one I'm not sure about is this. What unhandled kind is that? We skip, but we notify func. unless it's incomplete. Let's handle that as well. Yeah, so this was an incomplete type. This must be SDL window, if I'm not mistaken. That makes no sense. Why would... Oh, it's because we actually had a structure called incomplete. But there's probably other incomplete things. Well, no, I guess not in this one, but there's... Anyway, this is nevertheless correct. The other thing we want to do, which I forgot to add, is we want to do names. We can actually be clever and use this field we have already. No, I guess we can't. This is no, we can. It's a macro. So like that. Let's see. Well, for now, maybe we just do it like this and pass it in. And then for these different cases, so you can have a null name for things that don't really have names. Actually, that's not right. This has to be a quoted string. So if we do it like this, we have to break this into multiple parts. So the first thing is the kind, then generate if name, stir name false, else gen f null, and resume here with the remainder. Let's see, so generate this, generate a quoted string if name is provided, otherwise just have a null pointer for that field. And so we can just do it manually there. Yeah, just leave it null. Actually, yeah, for a pointer it should be null, for a const it should be null. For array it should be null. Maybe the right way to do it actually is to not get this thing involved at all. And do it as a later field since it's optional. 1, 2, 1, 2, 3, 1, 2, 3. No. So gen type info, this is all good. These should all be null. And then for this, you can do see here. No, I don't think this can be done in this way. It needs to be split up into the first part, second part, actually let's put this on one line the same way we do the other things. So first we have all this stuff. Oh, still not enough, because we have to finish off by closing the definition. So let's see here. Get the size, get the align of. This feels like an unbalanced definition. What did I do here? First the kind, comma, dot size, dot line, dot name equals quoted string, end of definition. I see. So that's at least one of the problems. Okay. This is the other one. No comma. All right. I'm tired, but I think this is pretty much it. In terms of the data we want to generate, and let me finish off by writing some code that actually uses it to do some kind of generic printing thing. I guess the first thing that would be fun to write is well, you can do some kind of print type info. I don't know what the word is. not really the name, stir. But it would go something like this. And then for the others, let's do stuff like type putter. So this is basically a version. Oops. I don't know. Yeah, I'm getting extremely tired and fatigued if I'm making these sorts of stupid typos. I'm basically making a version of the as expression dumper that we did back in the day. This is better. Okay. Now we should be able to say print type of actually let me say test type info. Let's make a separate function for all of this. And I want to call it at the end so none of the other junk intercedes. So I can easily see the output at the end. Okay, so that still works. Now let's say, let's first start easy. Let's say we do the same thing. Should just basically do what it was doing before, but now using the the name that's on the struct. But now we should be able to do stuff like this as well. So pointer to uchar, that's not right, actually. Why does it think that's a uchar? So let's say test type info 45. Let's use explicit. Let's use explicit designated initializers just so I can easily find what line they're referring to when I'm debugging. So this would be like that. I guess, yeah. Stuff should not use start with. It's probably for the better anyway to factor that out. And then neither should this, and neither should this. I think maybe the problem is that it hadn't regenerated the type info. This stuff is clearly insane. So suddenly all of the it's because I'm insane. So that was the bug. Except that my build system is stupid right now. Okay, so that was the bug. I think I'm still going to leave this just because it means that if you're debugging and you see like, oh, 43, that means that thing. Although let's do labels for the fields just so it's more readable. Unless error prone, if we reorganize the structures later. So yeah, now it's kind of easier to navigate this by eye if you are debugging. So 33 is what? 33 is a pointer to 30, which is a const, 3, which is a char. So pointer to const char, which is what you'd expect a name to be, but yeah, you can kind of easily navigate this now. Maybe later we will actually generate enums that have descriptive names for these entries, but for now this was by far the easiest way to do it, I think. And it's not too verbose. All right. So we haven't done function types. I don't know how useful they are for now because we don't have a way of calling functions. Like we would need an FFI or something to dynamically do that. So and enums right now we don't have enough data to generate good information for them. Um, maybe this is the right stopping point. Let me just see here. What are we not handling? We're not handling funcs and we're not handling enums. That's really the only thing. Of course, there's a bunch of utility functions you would want to write, like the stuff we just started writing in the ion code. But for me, the important point is the data structures and the generation of that type info. So I think that's good for now. I think I'll stop streaming and go get lunch. I'm pretty fatigued. But we managed to get done what I wanted to get done, which is great. So see everyone next time.